In this video, I'll introduce the second right-hand rule that we have for magnetism. This one tells you about the magnetic field that's created by an electric current. So up until now, we've looked at the effects of an external magnetic field on moving charges. Now we're going to look at there is no external magnetic field, but the wire carrying current itself creates a magnetic field. To determine the direction of this magnetic field, we have a new right-hand rule. Still, make sure you're using your right hand, put your left hand in your pocket, sit on it, do whatever you have to do. Write on your palm, this is my right hand. Okay? Make sure you're using your right hand, otherwise you'll get the opposite of the correct answer. So, as before, your thumb represents the direction of motion. So it's motion of a particle or direction of the current. So we're going to put our thumb in the direction of the electric current that's going through the wire. Then our fingers, before our fingers represented magnetic field lines, again, our fingers represent magnetic field lines. But this time, if we put our thumb in the direction of current, this is a wire that's going upward, if we put our thumb in the direction of that current, the magnetic field curves around the wire in the same direction that your fingers curve around your thumb. So in this case, my fingers on this side of the wire, on the left side, my fingers are curling out of the board. So that means on this side, the magnetic field's coming out of the page. This direction, so in front of where the wire is, my fingers curve to the right. So that means that out here in front, it's moving to the right. The magnetic field is pointing to the right. Over here, on this side of the wire, my fingers curve into the page. So that means on the right side of this wire, the magnetic field lines are going in. And remember, magnetic field lines do not have a start and stop. They're complete loops. So the magnetic field around this wire looks like a bunch of loops circling around this wire in this direction. So for example, if we have a current that's going downward, then at this position where I've drawn the star, the direction of the magnetic field created by this current at that location is, put my thumb in the direction of the current, curl my fingers around, and when they are on this side, my fingers curl into the board. So at that position, I can draw an arrow into the board. At this star, it's going in. If I look at this one, in this case, the current, shown by the X, is going into the board. So at the star location, if I put my thumb into the board and move to where I can put my fingers down here where that star is, my fingers curl to the left. So at this location, the field is to the left. In this example, I'll do the middle one. This is a dot with a circle around it. That means there's an arrow pointing out of the board. So if the current, my thumb, is pointing out of the board, then I'm drawing field lines. Up here, above, my fingers are curling to the left. So up here, the field is going this way. Over here, it's going down. At the bottom, it's going to the right. These field lines curl around this direction. So this is what the magnetic field looks like around a wire that's pointing out. For this one, you'll have to use X's on one side and dots on the other to show the direction.